Okay, so we're looking at Cambridge 4.1, question 9. And the reason this question is interesting for us is because it's dealing with multiple roots, and dealing with multiple roots is interesting because it allows us to investigate the derivatives. So here's the original function: px equals x to the 4 plus x cubed minus 3x squared minus 5x minus 2. And as we know from our polynomial theorems, that the any rational roots need to be divisors of the constant term. So we're looking at the options for roots being 1, minus 1, 2, and minus 2. And investigating all of those, we can come up with a few solutions. You would guess and check those, but to sub in p minus 1, you get minus 1 to the 4 plus minus 1 cubed minus 3 times minus 1 squared minus 5 times minus 1, and all of that adds up to 0. And using the factor theorem, that means that minus 1 is a root, and therefore x plus 1 is a factor of px. Okay, also, if you do all the substitutions, you can figure out that the other one of those is p2. And again, subbing in p2, we get 2 to the 4 plus 2 cubed minus 3 times 2 squared minus 5 times 2 minus 2, and you get 16 plus 8 is 24 minus 12. 12 minus 10 is 2, minus 2 is 0. And the other two don't work. So you found that your two zeros are minus 1 and 2, and that x minus 2 is a factor. Okay, so you already know two of the factors of px. Now, using the theorem that we investigated, you know that when you differentiate something that has a multiple root, that the derivative p dash x will also share that root. And so we're going to investigate p dash x, which is 4x cubed plus 3x squared minus 6x minus 5. And if you find that either of these numbers are zeros, then you've found that it's a multiple root. So p dash 2, which doesn't work, is 4 times 2 cubed plus 3 times 2 squared minus 6 times 2 minus 5, and that gives you, what's that, 8, 32, plus 12 is 44, minus 12 is 32, minus 5 is 27. Obviously that's, it's not a 0. And then if you do p dash minus 1, you get 4 times minus 1 cubed plus 3 times minus 1 squared minus 6 times minus 1 minus 5, and that gives you minus 4, plus 3 is minus 1, plus 6 is 5, minus 5 is 0. And there you have it. So that is a 0. And now you've determined, therefore, that 2 is not a multiple root, because of the fact that it doesn't work on the first derivative. You've determined that minus 1 is a multiple root because it has a 0 for px and a 0 for p dash x. So the next thing to do is find p double dash x and figure out whether it works for that as well. So p double dash x is equal to 12x squared plus 6x minus 6. When you find p double dash minus 1, you get 12 times minus 1 squared plus 6 times minus 1 minus 6, and that is 12 minus 6 is 0, so it works again. So it's a 0. So now we've got up to a third order root, or a multiplicity 3, because it works in the original, it works in the first derivative, and it works in the second derivative. And to see if it keeps working, we check the third derivative. And the third derivative is 24x plus 6, and p triple dash x minus 1 is 24 times minus 1 plus 6. That is not equal to 0, and we don't really care what it is, but it's minus 18, and therefore it's not a quadruple root. So px is a root, p dash x is a root, p double dash x is a root, and so because it works in 3 equations, it is a triple root. So as p minus 1, p dash minus 1, and p double dash minus 1 equals 0, x plus 1 is a triple root because it works in 3. So that's the multiple 0. We have shown that that's a multiple 0 by doing that, and we found that 0 and its multiplicity, and therefore we've done it. In addition, by the way, because we found that P2 was also a root, we found all 4 of them because it's order 4, x to the power of 4, and we found x plus 1 is a triple root, and we found x minus 2 is a root. And although this isn't necessary to answer the question, we do know as a result of that px is equal to x plus 1 to the power of 3 times by x minus 2, as they are all 4 of the roots, and x to the power of 4 has a coefficient of 1, and therefore it doesn't have any other things to make up that. That's it.